A very good evening to everyone. Welcome all on behalf of CyberT20 team. And today's session is all about Cyber Bytes. We are just planning to have a 20-minute short info about some cybersecurity concept. So that's what is the agenda. Everyone knows about CyberT20. So what we had in the last two matches, what we are going to have in the next four matches, do's and don'ts. And we are discussing on different domains of cybersecurity, specifically for awareness with respect to October Cybersecurity Awareness Month. And today's topic is about Cyber Bytes, and we have our guest, Mr. Prem from PITOWINGS. Just to give a short intro about him, he has an MTech in cybersecurity from Amrita University, and he has quite a good number of cybersecurity core technical certificates like OSCP, EC Council Encryption Specialist, International Forensic Science Certified Forensic Investigator, and on. And he's a proud founder and leader at PITOWINGS, a cybersecurity company. And the company is directly involved with government cybersecurity agencies, specifically dealing with NCCS, National Center for Cybersecurity. And they provide cybersecurity test use cases for ITSAR, information technology, security assurance, and requirements for government accredited labs, and many more initiatives from them. With a short intro, we welcome Mr. Prem to start his quick 20 minutes byte session.
So, good evening, everyone. Thank you for this opportunity to speak today. So, myself, as Ashok mentioned, I'm Prem, student of Ashok, of course, and I'm specialized in cybersecurity, focusing on predictive intelligence to protect critical infrastructures over the all digital ecosystem. So, today I will take you through an exciting topic like how protocol fuzzing can uncover hidden vulnerabilities before attackers do. So, basically, my goal is to give everyone a clear practical view of how we can stay one step ahead of the threats. So that's my goal. So here, as I mentioned here, like every empire or kingdom falls from within, right? Like not from the walls, but from the one unseen crack. And in cybersecurity also the same. The crack is the zero-day vulnerability, a flaw that no one even knows exists until an attacker finds it. So what I'm going to walk you through today is how protocol fuzzing helps us find those cracks before anyone else does. So, and this isn't just theory, like this is the method that's already being used by some of the biggest names in tech. Like you just name it, like the companies like Google, Microsoft, Tesla, SpaceX are already using it, implemented and using it to protect everything from cloud infrastructure to the IoT systems which we use in our day-to-day lifestyles actually. So the hidden war, like every digital interactions we have, like every API calls, every IoT handshakes, every cloud transaction, they all speak one common language, which we named as a protocol. It's basically the rule book for how machines talk to each other. But here's the scary part. When the rule book has even a tiny mistake, attackers can twist it, right? So they can say like just the right thing in the protocol's language, and suddenly they are inside the system, like our infrastructure. At that point, like whatever we have, like our firewall, our antivirus, any perimeter defenses we have, they will become useless. So the real war isn't just happening outside our systems, it's happening inside, like in the code itself that defines how everything communicates. Like that's what the protocol which we say. So the zero day reality is zero day are in some just kind of a fancy word or some movie plot. They are very real. So there are vulnerabilities no one knows about, not the vendor knows about it, not the defender knows about it. Only the attacker will identify and they know it very well. And when one gets exploited, the damage goes way beyond just fixing code. Like for example, you have got downtime, customer data at risk, complaints nightmares, and lot of reputations all at once will happen. And to make it worse, some of these flaws hidden for years, like before someone stumbles upon them. So the question arises in our mind is like, do we have 0 days? Or it's how many are quietly waiting in our software right now? That's the question we should be having all the time. So why we keep missing them regularly? So now in our organization, like we do have our testing teams, right? So now our testing teams do a great work, of course, but they are testing what should happen. Like that's what we call the happy path. But the attackers, like though, they live on that defensive part, like that chaos path, what we say. So they send wired inputs like out of order sequences and malformed data repeatedly, continuously, all the stuffs our systems were never meant to handle. So the old school fuzzers, of course, try to explore the chaos by throwing random junk at software, but they weren't smart. They would crash at the first checksum. Even a normal sanity attack itself, like they might be getting crashed. So they would generate like millions of, normally as a fuzzing expert, like what I will do is like I will generate millions of useless cases, but never hit the real danger zone itself. So that's how a normal tester we do work. So what we basically been choosing between slow and manual, or fast but not dumb, but dumb, of course. That's what we do regularly. To find 0 days, we need something that's fast and smart, right? So this is the thing which I'm coming to propose, like enter the hunter, like which I call the name like fuzzing. So let's simply, what fuzzing actually is, like think of an something that curiosity, like automated curiosity itself. Imagine a super curious intern, he himself, who keep pressing every possible button on your application, okay, sending random data, continuous random data, rough data, which has should not be sent, like doing all the weird things, like whatever we never expect. Then nothing, what it gets breaks, right? So that's what the fuzzing is. Like it's like stress testing your code with randomness. That's what simple fuzzing means. From the chaos which we've seen already, it discovers patterns, and those patterns like generally reveals bugs we never ever even know existed. So in simple terms, like what we can say is like fuzzing is how we find the invisible cracks before they turn into a 0 day. That's what the purpose of fuzzing means. So this evolution, like from the initial stage of like the dumb chaos, what I used to say, and to the smart intelligence, right? Now fuzzing itself has evolved a lot. The concept of fuzzing, like how the fuzzing works, how we getting matured itself, evolving day by day. So at first it was a pure chaos, like mutation fuzzing, where we just flip bits and hoping something crashes. That's the initial stage the testers used to work. Then comes the model-based fuzzing, which try to be smarter, but look ages to set up. The setting up cost, like everything will go beyond our estimated budget itself. And finally, the coverage guided fuzzing, which I named it here as like CGF, what I used to say. This is where things getting interested. CGF doesn't just guess; it learns actually. It looks at how the software reacts and says, okay, that input took me somewhere new. Let's focus more there. It's fast, it's adaptive, and of course, it's incredibly precise. Basically, it's the in general terms, like in the attacker perspective, I used to say it as a sniper of fuzzing. This concept, what I defined. So, to look inside the 0 day killer, so how this CGF really works means, like first, it's instruments, right? Instruments the code, meaning it watches every single line that gets executed. Then what an input causes new code to run, code that never been reached before. It marks that input as interesting. So this is how it's worked. Like now, instead of starting over, it takes the input itself, mutates it a little, and tries again. It's like a playbook kind of a thing, like a reinforcement learning kind of a thing, which we work over and over. It's like evolution. Like every generation of inputs gets smarter, exploring deeper and deeper into the logic. And here's where it became really powerful for protocols, because like protocols are stateful. For example, a vulnerability might only show up after a specific 3-step handshake, right? So the state aware fuzzers like actually learn those sequence and repay them perfectly to expose deep logic flaws. So what used to be a game of luck, just hoping to crash something, has now become a great, let's say like a scientific methodological hunter for 0 days itself. So the real world power, this isn't just a research idea actually. As I mentioned you, CGF is already running inside the biggest tech companies like Google, Microsoft, Apple, Tesla, even SpaceX runs it. And they all have one reasons, because like it works for them. It finds up 10 times more critical vulnerability than old fuzzers. So instead of hoping someone reports a bug, they are discovering them automatically long before an attacker does. That's the advantage here. It's basically turning 0 day discovery from a matter of luck into a repeatable, we can even say in our terms like predictable process, right? So coming to the business equation, now let's put on a business hat for a second. Like the return of investment here is crystal clear. Preventing a 0 day is far cheaper than surviving one, because the breach will cost a lot, right? Generally, we hear daily about the 0 day and its impact and the losses, right? We are taking no emergency patches, no downtime, no compliance fines, and no late night crisis meeting by preventing this 0 day. That's what we achieve. So plus fuzzing doesn't just find security bugs, it finds crashes and also the memory leaks and even some of the quality assurance side, the performance issues that also will be covered in this security assessment of fuzzing. All the quality problems that hurts user experience too. So we get 3 wins here, like stronger security, better stability, and the higher trust. That's why I like to say fuzzing isn't a security cost, it's a reliability investment actually. It makes both our system and our, of course, the company's reputation much more stronger in a regular way. So the strategic move here is like, so what's the move from here we need to take, right? We shall start from the scratch and scale fast. So I'm proposing a 4-week pilot, like forcing on 3 of our highest risk protocol interfaces. Even we can start working on the HTTP, HTTPS, even the ICMP protocols. Like let's say when we come to IoT, we can take MQTT protocol. Let's start from there. And during the time, like we will measure real metrics like coverage growth, number of crashes found, and how quickly we fix them. That's the point of the purpose of doing this fuzzing. So if it performs the way we expect, fuzzing becomes a standard gate in our the DevOps CI/CD pipeline, right? The process for all its critical updates. So that means every new protocol changes goes through the 0-day killer before it even reaches the production environment. So by having this fuzzing in our CI/CD pipeline, everything sets up right. So even like how we do the SCA, how we do the SAS, how we do the DAST, we need to do this fuzzing assessments as well. So finally, the closing impact, the truth is like the next 0 day isn't out there in the wild. As I mentioned you already, it's already in our code. That's how we need to believe. Then that comes the insisting way how we force ourselves to the proceeding with the fuzzing itself. So mainly that CGF gives us the power to find it before anyone else does. By bringing this into our development pipeline, we were not just securing the outer layer, we are securing the foundation itself from the place where we code. Every vulnerability we catch early saves us millions in potential damage, of course, like protect our brands, keep our customers' trust intact, everything. So let's make 0 day something we talk about preventing, not something we clean up after. To give you some more insights, so Indian government expectations for protocol level testing, this is 100% true information. Actually, we are even working on it. Indian authorities like aren't just treating fuzzing as an optional technical curiosity anymore. Like certain and mighty expect formal security testing that includes protocol level checks. Even for telecom and 5G components, the NCSCS and certain notices explicitly call the fuzz testing for specific interfaces. That means when we run fuzzing, we must treat it like audit evidence. Keep the seed corpus, record crashes, triages, and classify severity, log fixes, and even the regression runs, which generally relies on the QA. And we will be able to show who owns each step. That's the main point. Like we will be having the 100 test cases. Let's take this as an example. Each test cases will be run by a particular engineer, right? For example, first 40 test cases will be run by the single engineer. Next 10 cases will be another engineer. So here we can make sure like who runs which one, who is responsible for each testing, each assessment, everything will be covered in this structure. So practically, we should integrate this CGF, what I mentioned you, into CI/CD, like which stores the reproducible crashes artifacts and engagement empanelment auditors where we need formal attestations. For the pilot, like we will produce a something like a baseline report, and maybe we can even have a exact checklist items you see here. And then of course, like, so we are not only finding bugs, we are we are even proving we follow the right process, right? So that's it. Like, all right, I will pause here and open it for any questions if you have, like anything like related to technical, strategic, or business. And just to address the common ones up front, we don't always need source code to first. Yes, it runs in parallel with the builds itself, as I mentioned you, to come up with the CI/CD pipeline itself. So it won't slow down the development, and both security and dev teams can able to share the maybe the results for the faster implementation or faster output, faster triage, what we say. The mission is simple here. Let's make 0 day extinct in our environment before they even get the chance to exist. So that's it, sir. Thank you everyone for your time.